Hi, I'm Tanish, and this video is about the fundamental counting principle. You don't need to already know a lot of things for this topic. This is mainly used in probability.
Stacy has two blouses, three skirts, and two pairs of shoes to choose from. How many different outfits does she have to choose from? So the problem is asking us to find the different possibilities of outfits Stacy can wear. So there obviously are two blouses. So there's blouse one, and there's blouse two. Okay. Whether you choose blouse one or blouse two, you have to choose one skirt, right? So there are three different skirts. So there's skirt one, skirt two, and skirt three. And then after that, you have to choose a pair of shoes. I wrote down all the different possibilities, and now I just have to count them. So if I choose blouse one, skirt one, and shoe one, that's a possibility. Blouse one, skirt one, shoe two, that's another possibility. Like blouse one's skirt two and shoe two, that's a possibility. So I just keep on counting them. So if I count all of these, I have six over here, and I have six over here. I just add them together and have the total number of possibilities, and that would be 12. This obviously is a very annoying method to keep writing out, right? And if you have a much more difficult problem that lasts for, I don't know, 5 of these, 10 of these, and 6 of these, it will probably take forever to write it out and then see what's there. So there must be a much easier way to solve this. The way you can solve this quickly is with the fundamental counting principle. What the fundamental counting principle says is that if I have two events, event A and event B, oh, event B. So the first event A can occur in A different ways, and event B can occur in B different ways. So what are the different ways that both the events can happen? A, B. So the counting principle says that it would be A times B. That would be the different ways both the events will happen. So if you probably didn't understand what I said by just saying the words out. So I think it's best if I show you what I mean. In the Stacy's outfits problem scenario, we can apply the fundamental counting principle like so. We have three different events: the blouses, the skirts, and the pair of shoes. So the different blouses are two, and the different skirts are three, and the different pair of shoes are two. So if I write them down, the blouses there are two, skirts there are three, and the shoes are two. So the fundamental principle says that if we multiply these numbers, we should be able to get the answer. So if we multiply 2 times 3 times 2, we get 12. And when we listed all the possibilities out previously, the answer we got is also 12. Let's try a different problem. A license plate for a particular state has 3 letters followed by 3 numbers. How many different license plates are possible? So if you would have blindly followed what we did in the last problem, you would say that since there are 3 letters and 3 numbers, shouldn't it just be 3 times 3? That's why you don't blindly follow things, because it's not 3 times 3. Because if you read the question carefully, it says there are 3 letters and there are 3 numbers, right? So they didn't ask for the different possibilities of numbers and letters. They asked for the different possibility of license plates, the different license plate possibilities. All right. So if we were to write, there'd be 3 letters. So letter 1, letter 2, and letter 3, and then 3 numbers. Number 1, number 2, and number 3. What we have to do is multiply all the possibilities for these. So the number of possible letters would be 26, because there are 26 letters in the alphabet. And then this would also be 26. This would also be 26. And then possibilities of numbers would be 10, because it can go from 0 to 9. And that would be the digit that they have in the license plate. So 10, 10, 10. So this is the possibility that we should multiply with. So we should multiply 26 times 26 times 26 times 10 times 10 times 10. This, if you multiply it out, you get a huge number, which will be 17,576,000. So you'd get 17,576,000.